Welcome to Math 9 class with Ma'am MC, Ma'am Forts, and Sir Reynold. Today, you will be learning theorems of rectangle, rhombus, and square. But before we proceed with those theorems, let us first define a theorem. So a theorem is a statement that needs to be proven. It can be demonstrated to be true by accepted mathematical operations and arguments. Now, the process of showing a theorem to be correct or to be true is called a proof. So we are going to prove theorems. And you may be familiar with the word postulate. So a postulate, on the other hand, is a statement that is assumed to be true without any proof. So the difference between a theorem and a postulate is that in theorem, it is a statement that needs to be proven before we accept it as a true statement or a fact or a mathematical concept. But in postulate or a postulate is a statement that don't need proofs. It is already assumed to be true without any proofs. Now let us have our first parallelogram. So a rectangle is a parallelogram with four right angles. So you have already learned the different properties of a parallelogram. If a parallelogram has four right angles, we can call that parallelogram a rectangle. So this is your rectangle, and in this it has four right angles because we all know that a parallelogram has four interior angles. So if that parallelogram has four interior angles and those four interior angles are all right angles, then we can say that that parallelogram is a rectangle. So this is the special property of your rectangle that will set it apart from all other parallelograms. Now we have here theorems related to rectangles. We have the first theorem. So theorem 1 for rectangles states that if a parallelogram has one right angle, then it has four right angles and the parallelogram is a rectangle. So this is the first theorem on rectangle and we need to prove this one. Actually, this has been proven already. So this can be considered a fact already or a property of your rectangle because this has been proven. Now, what we are going to do is to show you the proof for this theorem. The second theorem for your rectangle states that the diagonals of a rectangle are congruent. So we will be proving two theorems on rectangle. As I have said, theorems need to be proven. So we will be proving, or I will be showing you the proof for theorem number 1. So theorem number 1 for rectangle states that if a parallelogram has one right angle, then it has four right angles and the parallelogram is a rectangle. So if you are given a parallelogram and that parallelogram has one right angle, you can already say that it has four right angles and that parallelogram is actually a rectangle. So we will be proving here that given only a parallelogram and one right angle, we can already call that parallelogram a rectangle. So in proving, we always start with a given statement. So our given statement is LOVE is a parallelogram with angle L as its right angle. We always start with a given because this will be our basis for the other statements that we will be using in trying to prove our theorem. So this will be the start of our statement. So given, again, LOVE is a parallelogram with angle L as its right angle. So this is our parallelogram, LOVE. This is not yet a rectangle. We will be trying, or we will try to prove that this is really a rectangle, given that there is one right angle. So we call this parallelogram LOVE. You can also call this one as parallelogram OVEL, or you can have VELO or ELOV, or pwedeng baliskad, OLEV, something like that, just as long as pasunod ang aton nga letters according to the figure. Now, so we have the given statement. We will be proving that this parallelogram LOVE is a rectangle. So our given here is a rectangle, or a parallelogram rather, with right angle at angle L. So we will be proving that this parallelogram LOVE is actually a rectangle. Now we will have the proofs. So in proving, um, we will have two columns for this one. The first column will include statements, our statements based on our given or based on the theorem, based on what we are trying to prove, etc. And we will have the reasons. These reasons will support our statement. We cannot simply say that, okay, LOVE is a parallelogram with angle L as its right angle. What is our basis? So we need to prove, we need to have a reason or a proof to that statement. Now, we will have the first statement. Our first statement, again, will be our given. We will start from this one. So, our given is LOVE is a parallelogram with angle L as its right angle. So what supports that statement? So how can you say that LOV is a parallelogram and it has a right angle at angle L? So we have here the given. So the reason for that one is given. So we start with the given and we start with the reason, which is the given. Okay? Now, from that first statement, we will be drawing another statement, a conclusion. So, we will have an idea, we will be deriving idea or ideas from our given statement. So, our first statement is LOV is a parallelogram with angle L as its right angle. So, since angle L here is a right angle, what can you say about it? Or how do you call, or what is the measure of right angles, or what are the measures of right angles? Okay, so since angle L here, as stated sa first statement natin, is a right angle, we know that a right angle is an angle which measures 90 degrees. So if angle L is a right angle, then we say measure angle L is equal to 90 degrees. So, wala ko yung batang unit, but the unit for angles will be degrees. Not degree Celsius, not degree Fahrenheit, not degree Kelvin. It's just degrees. So measure. This M here is our indicator or our symbol for measure. This one, which is a less than symbol, actually it's not a less than symbol, but maybe, syempre pahapos lang si ma'am nyo, so less than lang. But there is a symbol in Microsoft Word for angle, which is, ang anang nga isa ka leg, dapat flat ta na sa surface or dapat horizontal ta na. It's not inclining like sa aton nga less than symbol. But we can consider this one as the symbol for angle. So this is measure angle L. This one here, angle L lang. This one, because we have here M before the less than symbol or the angle symbol, then we will be calling this one measure angle L. So we read this one measure angle L, which is equal to 90. So what supports this idea? How can you say that measure angle L is equal to 90 degrees? Okay, so measure angle L is 90 degrees because it was stated from the first statement that angle L is a right angle. And we know that right angles measure 90 degrees. So if measure angle L or if angle L is right angle, then it measures 90 degrees. So our reason there is the definition of right angle. So a right angle is an angle which measures 90 degrees. Now, let us have the third statement. Your third statement does not need to be taken or a part of your second statement. Pwede man balik ka sa first statement or some ideas which you can draw from all the given or from all the statements given here. So we will have angle L is congruent to angle B and angle O is congruent to angle E. Now let us go back to our figure. Where is angle L located? So this is your angle L. This angle L is congruent to angle B. This is your angle B. So they are opposite angles. So how can you say that angle L is congruent to angle V? And likewise, angle O is congruent to angle E. So this is angle O. Opposite of that is angle E. So they are congruent. So what supports that idea that our opposite angles are congruent? So what will be our reason? So our reason for that is, in a parallelogram, opposite angles are congruent. So this is one of the properties of the parallelogram. Opposite angles are congruent. So we have here angle L. Opposite of angle L is angle B. Since this is a parallelogram, then we can say that angle L and angle B are congruent. Angle O is opposite angle E. So this is a parallelogram, so therefore we say angle L, or angle O rather, is congruent to angle E. So again, angle L is congruent to angle B, and likewise, angle O is congruent to angle E, because in a parallelogram, opposite angles are congruent. Next, number 4. Since angle L is congruent to angle V, then we can say that measure angle L is equal to measure angle V. Now try to notice here, we are using the angle, just the angle. We don't we only have the angle. Here, we mean the measure. So if angle L is congruent to angle B, then we can say that the measure of angle L is equal to measure angle B. Now here, because we are just using the angle, we will be using the symbol for congruency, or we will be using congruency. Here, because we refer to the measure of our angles, then we say equal. So if angle L is congruent to angle B, then measure angle L will be equal to measure angle B. And likewise, if angle O is congruent to angle E, then we say measure angle O is equal to measure angle E. And that is because of the definition of congruent angles. So the definition of congruent angles are angles which are equal in measure, or, of course, if two angles measure the same or equal, then they will be congruent angles. Now, if measure angle V, measure angle, fourth or fifth statement rather, measure angle V is equal to 90. So, what made you say that measure angle V is equal to 90? So we have here the following statements. Angle L is congruent to angle V. Measure angle L is equal to measure angle V. So how can we say that measure angle V is equal to 90? It's not given, right? So it's only the angle L which is given to be a right angle. So how can you say that measure angle V is equal to 90? Now, measure angle L is equal to measure angle V. And we know that measure angle L is equal to 90 because angle L is a right angle. So therefore, we can conclude that measure angle V is also equal to 90 degrees. Kaya kung hindi na mag-90, then they will not be equal. So since measure angle L is equal to 90, then measure angle V is equal to 90 degrees. And the reason for that, we use the transitive property of equality, wherein if measure angle L is equal to 90 and measure angle L is equal to measure angle V, then we can say measure angle V is equal to 90. It's about eliminating the like variables here. So this is measure angle L, this is measure angle L. So we have come up with 90, which is equal to measure angle V. We can also use substitution property here. So measure angle L is equal to measure angle V. We will be substituting the measure angle L here by its value. The value of measure angle L, or measure angle L, is equal to 90. So therefore, 90 is equal to measure angle V. So measure angle V is equal to 90 degrees. So again, you can use the transitive property of equality, or you can also use the substitution property of our equality. Now let us have the sixth statement. Measure angle L plus measure angle O is equal to 180. So where is angle L? This is angle L, this is angle O. So what can you notice about angle L and angle O? What is the relationship between angle L and angle O? So begin na, we have angle L and angle V. Angle L and angle V are opposite angles. So opposite angles in a parallelogram are congruent. How about angle L and angle O? So it is very important for us to know the relationship of our angles toward each other, so that we will know the measure of the angles, especially if we are dealing with parallelograms. So angle L and angle O are consecutive angles. Kasundan na yung sanda. Kumbaga daw, sa kilid tanda sang isa ka isa. So, we all know that in a parallelogram, consecutive angles are supplementary. So, it is very important for you to memorize or to know the different properties of parallelogram because you will be using those concepts in trying to prove theorems. So be familiarized with those properties of parallelogram, most especially. Now, angle L and angle O again are consecutive angles. Kasundan na yung sanda. Now, angle L and angle O are consecutive angles, and in a parallelogram, consecutive angles are supplementary. So, what does it mean if we say supplementary angles or supplementary? Now, supplementary angles are angles whose sum is equal to 180 degrees. So that means to say, if angle L and angle O are supplementary angles, then if we add their measures, the answer or the sum would be 180. So that is why we have here measure angle L plus measure angle O is equal to 180, because again, in parallelogram, consecutive angles are supplementary. Supplementary means the sum of their measure is equal to 180 degrees. Next statement. 90 plus measure angle O is equal to 180. Now, where did we get this 90? Going back to our sixth statement, measure angle L plus measure angle O is equal to 180. Now, by substitution, which is our reason here, we replace measure angle L by its value, and its value is equal to 90. So therefore, we say 90 plus measure angle O is equal to 180. So again, it's by substitution. We are replacing the value of our angle L by 90 degrees. So 90 plus measure angle O is equal to 180 degrees. Then we come up with the eighth statement. Measure angle O is equal to 90. Again, I've been saying 90 degrees, 180 degrees because the unit of measure for angle is degrees. But syempre, wala lang na dyan ginbutang because we are dealing sometimes with equations. So for you to not be confused, then I have removed the unit, which is the degrees or the degree. So don't forget lang, if you have the final answers, especially if you're dealing with the measures of angles, then you will be using degree as a unit of measure. Now, measure angle O is equal to 90. So 90 plus measure angle O is equal to 180. Measure angle O is equal to 90 by addition property of equality. So addition property of equality states that if you add something on the left side of your equation, you must add that number or that value or that particular thing to the right side as well. So here, for this equation, we will be adding something here to get rid of this 90. We will be removing this 90 from this equation so that we will have the measure of angle O. So what will you add to this side of the equation to get rid of this 90? So 90 here is positive. So we will be adding the additive inverse of 90 to this side to get rid of this 90. The additive inverse is just the value or the number which has the opposite sign sa aton ni given. So if we have here 90 to be positive, its additive inverse is negative 90. So we will be adding the left side of your equation here by negative 90. So that 90 plus negative 90 is actually 0. And we will do, of course, that 1 sa aton nga right side. We will be adding 180 by negative 90. 180 plus negative 90 they are of opposite signs, so we need to subtract. So 180 minus 90 is equal to 90, and it's positive. So we say measure angle O is equal to 90 degrees. So that is by addition property of equality. We have added negative 90 to both sides of the equation to get rid of our 90. Or we can simply transpose 90 to the other side of the equation. So transposing 90 to the other side, we will have negative 90. So that is 180 minus 90. That is still 90. But in proving, we use properties. You cannot say nga, okay, measure angle O is equal to 90 degrees. Tapos ang imong reason is transposing. We cannot use that one in mathematics or in reasoning or in proving. We use addition property of equality instead. And then measure angle E is equal to 90 degrees. So why is measure angle E equal to 90 degrees as well? So we know here from statement number 4 that measure angle O is equal to measure angle E. So if measure angle O is equal to 90, that means to say measure angle E is also equal to 90 degrees. So that is by transitive property of your equality. So if measure angle O is equal to measure angle E and measure angle O is equal to 90, then measure angle E is equal to 90 as well. Or you can use substitution. So we will have the 10th statement. Angle O, angle D, and angle E are right angles. So we have here measure angle D is equal to 90. Measure angle O is equal to 90. Measure angle E is equal to 90. So we say angle O, angle D, and angle E are right angles. Why? Because we know that if the measure of an angle is 90, then it is a right angle. So therefore, angle LOB is a rectangle because it has how many right angles? We have here 1 for the angle L, 2, 3, 4. So we have 4 angles which are right angles. So we say that parallelogram LOBE is actually a rectangle. So that is by definition of a rectangle. So we have here angle L, angle O, angle D, and angle E are right angles. So we have just proven, or I have just shown you the proofs for this theorem number 1 of your rectangle. Now let us proceed with the second theorem on rectangle. Theorem number 2 states that the diagonals of a rectangle are congruent. Now given CARE is a rectangle with diagonals segment CR and segment AE. So we have here our figure. So this is our rectangle CARE, and then we have our diagonals segment CR, or you can call this one segment RC as well, and our segment AE or segment EA. Now a diagonal is a line segment which connects two non-adjacent vertices in a polygon. So in a rectangle, since we only have 4 vertices here, so a diagonal is drawn from one vertex to its opposite vertex. So we have here our first diagonal is diagonal CR, and our second diagonal is diagonal AE. So we need to prove that these two diagonals are congruent. Let us now have the proof. So we have here our statements on the first column and our reasons on the second column. Now our first statement again will be our given statement. So CARE is a rectangle with diagonals segment CR and segment AE. Now our reason for that, of course, is given. And then for the second statement, we need to draw a conclusion, or we need to derive a certain idea from our given or from our theorem, or maybe from our figure. So our second statement states that segment CE is congruent to segment AR. Where is segment CE? This is segment CE, and this is segment AR. This is side CE or side AR. Now, these two are congruent. So how can we say that these two segments or sides are indeed congruent. Now we have this property in your parallelogram which states that opposite sides are congruent. Since rectangle is a parallelogram, it has also all the properties of our parallelogram. So therefore, opposite sides of a parallelogram or of a rectangle as well are congruent. So CE and AR are opposite sides. So therefore, they are congruent. So again, CE is congruent to AR. For the third statement, we have angle CER and angle ARE are right angles. So where is angle CER? So this is angle CER, this one. And then we have here our angle ARE. Now, these two angles are right angles. So what is the proof for that? So the proof for that is our definition on rectangle, which states that a rectangle has four right angles. So angle CER is congruent to angle ARE. We can also use, of course, our theorem number 1, which states that if there is one angle in your rectangle, then it is four right angles, and the parallelogram is a rectangle. Now, this angle CER and angle ARE are right angles. So that is maybe the best reason for that is definition on rectangles, not theorem 1 on rectangles. Because on the definition itself, rectangles are parallelograms with four right angles. So since we are dealing with CARE, which is a rectangle, then we can say that it has four right angles. So these two angles are right angles. And then, since angle CER and angle ARE are right angles, we can say that angle CER is congruent to angle ARE because all right angles are congruent because all right angles measure 90 degrees. So these two angles here are congruent. Now, angle ER or segment ER is congruent to segment RE. They are just the same. So this is segment ER and this is also segment RE. They are just the same and they are equal. But ER here is part of this triangle. Okay? So this is one triangle and part of this triangle is our segment ER. And then this is another triangle. And part of this triangle is your segment ER or your segment RE. So the segment ER of this triangle is just the same as the segment RE of this triangle. So they are just equal or congruent. So we will be using reflexive property of congruency for the reason. So if we will be using here equal sign, then we can say reflexive property of equality. But since we are using congruency, so we say reflexive property of congruency. Reflexive property states that a number is equal to itself. A segment is equal to itself. A thing is equal to itself. So it's like mirror. So the same lang. So ER is actually equal to RE because they are just the same segment. So that is reflexive property. Now, we have proven that ER is congruent to RE. ER again is part of this triangle. RE is part of this triangle. We are trying to establish proofs that these two triangles, na mention ko, are congruent to each other. Okay? So, dyan kita malabay nga way to prove our theorem. So, we need to prove that these two triangles here are actually congruent. And there are different postulates to support the congruency of our triangles. If you can still remember, we have the SSS, congruence postulate. We also have the SAS. We have the ASA. We also have the SAA. So those are the different congruence postulate that we can use to prove that two triangles are actually congruent. Now, ER again is part of this triangle. RE is part of this triangle. Now, going back here, angle CER, this angle, is part of this triangle. And our angle ARE is part of this triangle. And then going back here, CE is part of this triangle. And this AR is actually part of this triangle. So we have here how many congruency? We have 1, 2, 3. We have proven 3 corresponding parts of our triangles to be congruent. So we can therefore say that the 2 triangles are actually congruent. So where are those triangles? So this is ER and RE. And then we have here this first triangle, okay? So this first triangle is congruent to our second triangle, which is this one. So triangle CER, the orange one, is congruent to our triangle ARE, which is the pink one, because of SAS congruence postulate. Remember, this segment CE or side CE is congruent to this one. So they are 2 corresponding sides and they are congruent. So we have S side. And then we have A, the angles. This angle on the orange, which is the CER, is congruent to this angle, which is ARE of this pink triangle. So these 2 angles are corresponding angles and they are congruent. So we have A. And then another side. So this ER is part of this orange triangle, and this is equal to the RE or ER of this triangle or of this pink triangle because of reflexive property. So we have side, angle, side, side, angle, side. So that is why we will be supporting the congruency of our 2 triangles by SAS congruence postulate. Side, angle, side. So if we can prove that the 2 corresponding sides of our triangles are congruent and 1 pair of corresponding angles, which is the included angles of our triangles, are also congruent, then we can say that the 2 triangles are congruent. Now, since these 2 triangles are congruent, then we can say that all the other corresponding parts of those triangles are also congruent, and that includes our CR or segment CR and our segment AE. Segment CR is part of the orange triangle. Segment AE is part of the pink triangle. So since these 2 triangles are already congruent, then we can say the other corresponding sides are also congruent, and that includes your CR and your AE. So these 2 sides are also congruent by CPC-TC. So what is CPC-TC? Corresponding parts of congruent triangles are congruent. So if you have already proven that the 2 triangles are congruent, all the rest of the parts of your triangles are also congruent. So we have just proven that CR, which is the diagonal, one diagonal of your rectangle CARE, and AE of the rectangle CARE are congruent. So indeed, theorem number 2 for a rectangle, which states that the diagonals of a rectangle are congruent, is true. Now let us proceed with the second parallelogram, which is the rhombus. So a rhombus is a parallelogram with 4 congruent sides. Again, a rectangle is a parallelogram with 4 right angles. This time, we will be dealing or we will be focusing ourselves with the sides of our parallelogram. If a parallelogram has 4 congruent sides or 4 equal sides, then that parallelogram is considered a rhombus. So if it's singular, then it's rhombus. If it's plural, you can say rhombi. Usually, we are using rhombi as in RHOMBI. So that is the plural form of our rhombus, rhombi. But we can also use rhombuses as the plural form of our rhombus. Now, we have 2 theorems on related to rhombus. We have theorem number 1 states that the diagonals of a rhombus are perpendicular. Again, now we have the rectangle. Diagonals of rectangle are congruent. This time, the diagonals of our rhombus are perpendicular. And Each diagonal of a rhombus bisects opposite angles. So this is our rhombus. So it is a parallelogram, and it has four equal sides, or four congruent sides. So this one is a tick mark, or the symbol for equality for our figure. So if you have this one, this is to indicate that this side of this rhombus is equal to this side, equal to this side, and equal to this side. So it has four equal sides. Theorem number 1. So the diagonals of a rhombus are perpendicular. So what does it mean if we say perpendicular, or perpendicular lines? So perpendicular lines are lines which form right angles. So as long as we have perpendicular lines, perpendicular segments, perpendicular rays, then we will be forming right angles. So if you think of perpendicularity, or perpendicular in particular, then you will be thinking, or what comes into your mind after that is the word 90 degrees, or right angles. Okay, because if we have perpendicular lines, then we will have 90-degree angles, or angle. Now, we have here given rhombus LIVE. So given rhombus LIVE, so again, it is a rhombus, so you need to think of all the properties of the parallelogram, and of course, the special property of the rhombus, which is all sides are congruent. So given rhombus LIVE, we need to prove that LV is perpendicular to IE. So this segment LE or LV is perpendicular. So this is the symbol for perpendicularity. So this is an inverted letter T. So LV, or segment LV, is perpendicular to segment IE. So what is LV? LV, as you may notice here, is actually a diagonal. So LV is one diagonal of the rhombus, and IE is also the other diagonal of our rhombus. So we need to prove here that these two diagonals are perpendicular. So later we will be we need to show that there will be right angles that will be formed after the two diagonals intersect. So let us have the proof. Again, on the first column, we have the statements. On the second column, we have the reasons. We will start with the first statement, which is the given. So, given rhombus LIVE. Now, again, we draw conclusion, we draw ideas coming from our given, or from our theorem, or from our figure. So, we have here segment IV is congruent to segment LI. Where is IV? This one is segment IV, and this one is segment LI. So these two, according to our second statement, are congruent. So why is that? So what can we give as a reason to prove that these two sides here are actually congruent? So we will have the definition of a rhombus. Li is one side of our rhombus. Ib is one side of our rhombus. So remember, when we say rhombus, by definition, it is a parallelogram with four equal sides, or congruent sides. So therefore, Li and Iv are congruent. Third statement, LV and IE bisect each other. So where is LV? So this one is LV, and this one is IE. So what supports that idea that LV bisects each other, or LV, or our diagonals? These are our diagonals. Okay, so we have here the tick mark. I'm so sorry, I was too fast for that one. So we have here Li is congruent to IV. Again, this one is a tick mark, or it symbolizes equality. So Li is congruent to IV, or IV is congruent to Li. So we need to put a tick mark here to denote that these two sides are actually congruent. Now, next one. Again, we have here LV, one diagonal of our rhombus, and IE is the other diagonal of our rhombus. So it states here that these two diagonals bisect each other. So what does it mean if we say bisect? Bisect means it divides our side or our diagonals into two congruent sides. So if we have here LV is being bisected by IE, that means to say it passed through LV. And after passing, it divides LV into two sides. This one, from here, pakadto dyan, and then from here, pakadto dyan. And these two sides must be congruent because they are bisected or LV is bisected. Likewise, if IE is being bisected by LV, then we can say that this IE will be divided into two sides or two segments. This from here until here, and then from here until here. And again, these two segments are congruent because of the word bisected. So what made us say that LV and IE bisect each other? So we say the diagonals of a parallelogram bisect each other. So this is another property of our parallelogram which is useful in proving this theorem for our rhombus. So one of the properties of our parallelogram states that the diagonals bisect each other. Since rhombus is a parallelogram, then it has all the properties of our parallelogram. So one of the properties is this one. So the diagonals of a parallelogram bisect each other. So therefore, diagonals of a rhombus bisect each other. And then fourth statement, S is the midpoint of LV. So, IE bisects LV at point S. So, this is just naming the intersection of the two diagonals. So, the intersection of LV and IE is point S. So, this is the middle point here. So, we label it as point S. You can use other letters. It's up to you. But in this case, I have used point S. Next, SB is congruent to SE. Okay, now here, it's stated here that S is the midpoint of LV. It's not just the intersection. It is a special kind of intersection because S will be the midpoint of LV and S is also the midpoint of IE. So how can we say that it is the midpoint? Because again, IE bisects LV and LV bisects IE. So therefore, the point of intersection here will be the midpoint of the two segments. Now, SV. Where is SV? This one. SV is congruent to SL. So this SV is congruent to SL. So why is that? Because of the definition of the midpoint, because it was stated here that S is the midpoint of LV. So if S is the midpoint of LV, then that means to say it is the middle point. So it divides your LV or your side LV into two equal parts, namely your SV and your SL. So your SL and your SV are congruent to each other. Then we say IS is congruent to IS, or segment IS is congruent to segment IS. Now we are trying to establish here the congruency between two triangles. And what are those triangles? These two triangles, the triangle ISL, or this triangle, and triangle ISB, which is this triangle. We will be proving that these two triangles are congruent. So we have how many parts already? We have LI is congruent to LI. So that is already S. And then we have here LS is congruent to SB or VS. So this is another S. And then IS is congruent to IS. IS is part of this triangle. IS is also a part of this triangle. And we know that this IS is just the same as the IS on the other triangle. So therefore, this IS is congruent to IS by reflexive property. So for this triangle, we have three corresponding sides. We have LI, we have LS, and we have IS. And then for this triangle, we also have three corresponding sides. We have IB, we have VS, and we have also IS. So LI is congruent to IB, that is S. LS is congruent to SB, that is another S. IS is congruent to IS, so that is another S. So therefore, we can say that these two triangles are congruent by SSS congruence postulate. So again, angle VSI or triangle VSI is congruent to triangle LSI. by SSS congruence postulate. Side, 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 side. So SSS. Then, by CPCTC, angle BSI. Where is angle BSI? So this is angle. So there is a difference between triangle BSI and angle BSI. Triangle BSI is this whole green triangle. Angle BSI is just this one, nagapa-letter L. Okay? So this angle BSI is congruent to angle LSI. Because, again, CPC, TC, corresponding parts of congruent triangles are congruent. So we have already proven that these two triangles, the blue one and the green one, are congruent. So therefore, all the other parts or corresponding parts of those triangles are also congruent, including angle LSI and angle BSI. So angle BSI is congruent to angle LSI by CPC, TC. Now, angle BSI and angle LSI are right angles. They are congruent and they are also right angles. Why? Because angle BSI and angle LSI form a linear pair and are congruent. If we say linear pair, then they form one straight line. So this is your LSI and this one is your BSI. Notice that they form one straight line. So meaning they are linear pair. So if two angles are linear pair, or if they form a line, then and if they are equal or congruent to each other, then we can say that each angle measures 90 degrees. Kaya diba, one straight line here actually is 180 degrees. Then, we have here two congruent angles. So if you divide 180 by 2, then we will have 90 degrees for each angle. So, angle LSI will be 90 degrees. Measure angle BSI will be 90 degrees. So, therefore, these two angles are right angles. Because, again, if angles measure 90 degrees, then the angles are right angles. Now, therefore, i.e., this one is perpendicular to LV. Because again, once we say ganito perpendicular or perpendicular lines or line segments, they form 90-degree angles. And we have proven already that this one, this is your IE, this one is your LV, and we have produced how many angles here? We have your BSI and your LSI for your right angles. And it follows as well, the LSE and the VSE are also right angles. So we have formed four right angles with our diagonals. So therefore, our diagonals are perpendicular. Okay? Theorem number 2. So theorem number 2 on rhombus states that each diagonal of a rhombus bisects opposite angles. So aside from the diagonals of a rhombus bisect each other because of the property of the parallelogram, then we can also say by theorem number 2 that the diagonals of a rhombus bisects opposite angles. So again, we have here given rhombus LOVE. So we have here the figure and we have here certain angles. Now, we need to prove that angle 1 is congruent to angle 2. So this is angle 1 and this is angle 2. Angle 1 is actually angle LEO and angle 2 is angle BEO. And then angle 3 and angle 4 are also congruent. So that is angle LOE and angle BOE. Now let us have the proof. So we have here the statements and the reason. So for the first statement, again, we will start with the given. So rhombus LOVE or parallelogram LOVE is a rhombus. So the reason for that, given. Now we have number 2 statement. EL is congruent to OV. So where is EL? This one is EL and this one is OV. So these two are actually congruent. And LO, this one, is congruent to VE. So these two are actually congruent man. So definition of rhombus, because a rhombus has four right or has four equal or congruent sides. So LE and OV are congruent, LO and EV are congruent. Then So again, LE is congruent to OV, LO is congruent to VE. Now, OE is congruent to EO. Where is OE? So this one is OE and this one is EO. OE is part of this triangle perhaps. EO is part of this triangle, but they are just the same. So by reflexive property, this OE is congruent to EO. By then, triangle ELO is congruent to triangle OVE. So this light blue triangle is congruent to this dark blue triangle by SSS congruence postulate. So where is that SSS congruence postulate? This one is S, so side, side, and of course this side. So LE, LO, and OE. And then for the other side, we have the OB, the VE, and of course the OE again. So these two triangles are congruent. And by CPCTC, corresponding sides are corresponding parts of your congruent triangles are congruent. So we say angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Angle 1 corresponds to angle 2, angle 3 corresponds to angle 4. So therefore, angle 1 and angle 2, these are actually our two angles. So we have here angle LEV and angle LOV. Remember, we are trying to prove here that our diagonal or one diagonal of a rhombus bisect opposite angles. So if we try OE here, this OE will be bisecting our two angles, our LEV, angle LEV, and its opposite angle, which is angle LOV. So it will be bisecting. Bisect means we need our angles will be divided into two congruent angles. So matunga ta na. So this angle LEV will be divided into two congruent angles. And these two angles are this, angle 1 and angle 2. So we need to prove that these two angles are congruent. And then your angle LOV is or will be divided into two congruent angles such as the angle 3 and angle 4. So we have proven here that angle 1 indeed is congruent to angle 2, angle 3 is congruent to angle 4. So our rhombus or the diagonal of our rhombus bisects opposite angles. And likewise, if we will be drawing here our diagonal LV, then it will be dividing our opposite angles as well. Our opposite angles by that will be OLE and OBE. So it will be dividing. If we will draw here a diagonal, it will be dividing OLE into two congruent angles and OVE into two congruent angles. So that is the sense, or that is our theorem number 2 for rhombus. We are down to our last parallelogram, which is the square. So a square is a rectangle with all sides congruent. So it is a rectangle. That means to say all it is a parallelogram with 4 right angles, or all angles are congruent because all right angles are congruent. So we can say that a square is a parallelogram with all sides and angles congruent. Okay, so it has 4 right angles and it has also 4 sides which are congruent. So, kung may ginatawag man niya special parallelogram, it is the square because it has all the properties of the rhombus. It has also all the properties of the rectangle. And of course, because it is a parallelogram, it has all the properties of a parallelogram. And we have one theorem for our square. So the theorem states that the diagonals of a square are congruent and perpendicular. So if we are going to draw diagonals here, then we can say that those diagonals of our square are congruent and perpendicular. So again, it is a property which is a combination of the special property of our rhombus and our rectangle. Remember the first or the second property or the second theorem on rectangle states that the diagonals are congruent. And then for the rhombus, we have the diagonals are perpendicular. So since a square is a rhombus and a square is a rectangle, then the property would be the diagonals of a square are congruent and perpendicular. Let us prove. So we have your theorem, the only theorem for a square. So the diagonals of a square are congruent and perpendicular. So we have your given ABCD is a square. So this is our square ABCD. And since this is a square, so remember, all sides are congruent, all angles are congruent, or all angles are right angles. So we need to prove that AC is congruent to BD, or segment AC is congruent to BD. AC here will be the diagonal, and then BD here is also a diagonal. So we need to prove that these two diagonals are congruent, and also AC must be perpendicular to BD. So the two triangles, or the two diagonals rather, are perpendicular. So we will be proving two. We will be proving the congruency of the diagonals and as well as the perpendicularity of our diagonals. And this will be our given figure. So we have here AC is one diagonal, BD is one diagonal, point O here is our intersection of the two diagonals, which is also the midpoint for each diagonal. So we have here the proof. So statements. First, we have the given ABCD is a square. So given. Now, given that ABCD is a square, then side or segment AD is congruent to BC. First AD. This one is AD, this one is BC. So AD is congruent to BC. So this side is congruent to this side. Remember, we are trying to prove here that the two diagonals are congruent. So we will be establishing congruency between two triangles again. And what will be those triangles? We have the triangle ADC, this triangle, and triangle BCD, or this triangle. We will be proving that these two triangles are congruent because ADC includes AC, one diagonal. BCD includes BD, which is the other diagonal. So if we can prove that these two triangles are congruent, then we can say that AC and BD are also congruent because they are corresponding parts. Now, AD is congruent to BC. So this one, or this side of this triangle, is congruent to this side of this triangle. That's the property of a square. All sides are congruent. Measure angle BAD. Where is BAD? BAD. So this one sa babaw. Measure angle BAD is congruent to measure angle ABC. So this one. So this one is congruent to this one. Okay, now let's change that. We are now trying to prove that ADC, or triangle ADC, is congruent to triangle BCD. The other triangles. We will be proving the other triangles. Actually, we can do that. We can prove the ADC and the BCD to be congruent, but we will base on the given. So based on the given, actually the triangles that we are trying to prove to be congruent will be DAB and CBA. So these two triangles. So again, we have here the AD congruent to BC, corresponding parts. So that is already one pair of side. And then we have here your angle BAD, which is this one, and angle BCA, your angle ABC rather, ABC. So these two angles are equal in measure because again, property of the square, all angles are congruent, or all angles are equal in measure. Now, AB is congruent to BA. AB is part of this triangle of DAB. BA is part of this triangle, the DBC, or the CBA rather. So this AB is congruent to this BA by reflexive property. So we have here one side, one angle, one side. SAS. SAS. So therefore, these two triangles, the triangle ADB, okay, you can name this triangle ADB. Now, don't be confused, because you may say, Mom, this is triangle BAD. Yeah, you can say that this is triangle BAD. This is also triangle ADB. This can be triangle DBA. It's up to you. Pwede mo baliskad ABD. It's up to you. Just as long as pasunod ang aton niya names. So this triangle, this triangle here, which is named as ADB, pwede man ADB, is congruent to this triangle, which is called the angle or the triangle BCA. So this one is BCA. BCA, this one. Okay, so these two triangles are congruent by SAS. So this, we have side, angle, side. Here we have side, angle, side. So by SAS congruence postulate, we can say that these two triangles are congruent. And by CPCTC, corresponding parts of congruent triangles are congruent, we can say that AC, which is a part of this pink triangle, is congruent to this one, which is the part of this triangle. Now, I'm so sorry because I am not just consistent with the ordering of our triangles. Here, una natin always is ang the purple or ang violet na triangle. So we have BAD is part of the purple, AB is part of the purple, ADB is also the purple triangle. But here, nag-AC kita, which is AC is part of the pink triangle. And then, BD is part of the, kung bakit ito nag-interchange, that should be BD is congruent to AC. But by symmetric property of equality or congruency, they mean the same lang. But I have, kumbaga, I was just confused, or not confused, but nalipat lang ako nga i-interchange sanda. So, supposedly, ang pinaka-correct daan is BD is congruent to AC. Para at least may consistency ang aton nga proving. But, of course, again, by symmetric property, they mean the same. So, AC is congruent to BD. So, the thought is, these two diagonals are actually congruent. Okay? And then, we will proceed with the next statement, or the next thing that we are going to prove. We need to prove the perpendicularity of the two diagonals. We have already proven that the diagonals are congruent. So we will be proving that our two diagonals are also perpendicular. Now, OB. OB is congruent to OD. Okay, so this is for the first statement. Now, we will proceed with the second statement, and we will be using another figure. This is the same figure as the first one, Kagina. We will be separating this one so that you will not be confused with all the things going around, or all of the figures na add ko sa aton nga given figure Kagina. So, we will have here our square ABCD. So OB is congruent to OD. Where is OB? This one is OB and this one is OD. So remember, OB and OD are parts of BD. So how can you say that OB is congruent to OD? Because a square is a parallelogram and diagonals of parallelogram bisect each other. Again, O here is the midpoint of our diagonals. So that means to say it divides our diagonal into two congruent parts, such as for the BD we have OB and we have the OD. So these two are congruent. Next one. AB is congruent to AD. Where is AB? This one is AB, this one is AB, and this one is AD. This two. Okay? So based on this picture, we are trying to prove two triangles to be congruent. This triangle, the AOB or the BOA, it's up to you. And then we also have the AOD or the DOA. So we are trying to prove that these two triangles are congruent. So AB, which is part of this triangle, is congruent to AD, which is part of this triangle. And then AO is congruent to AO. So this side of this triangle is congruent to this side of this triangle because they are just the same. AO is just equal to AO by reflexive property. Now notice that for each triangle we have three sides. This is 1, 2, 3. Side, 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 side. So therefore, this triangle here, which is AOB, is actually congruent to this triangle here, which is AOD by SSS congruence postulate. And by CPCTC, measure angle AOB, this one, AOB, is equal to the measure of angle AOD. So these two angles here are congruent, or they are equal in measure, because they are the corresponding parts of the two congruent triangles. Now, since these two are congruent, measure angle AOB plus measure angle AOD is equal to 180, because remember, they form one straight line. So they are linear pair. And if they are linear pair, then that means to say the total of these two angles is 180. So AOB plus AOD is equal to 180. And since they are congruent, then we can just divide. So we can get the measure of one angle. So 180 divided by 2, that means to say angle AOB is equal to 90. Angle AOD is also equal to 90. So if angle AOB and angle AOD are equal to 90 degrees, then we can say that angle AOB and angle AOD are right angles. And since we have here two right angles already, then we can say that our side or segment AO, which is this one, and segment BD, which is this one, forms perpendicular segments because they have produced right angles. So this one, AOB and BD, are perpendicular, or we can extend this one, AC and BD are also perpendicular. So the diagonals of our square are perpendicular. So they are congruent and perpendicular. So that is the theorem for our square. Actually, we don't need to prove this one. We have already proven that diagonals of our rectangle are congruent and diagonals of our rhombus are perpendicular. So if we put them together, then we can also say the theorem for square, which is the diagonals of the square are congruent and perpendicular. And we're done. So as I have said, these theorems are need to be proven. But these theorems that we have discussed are existing theorems already. They have been proven by mathematicians a long time ago. So what I did was to show you those proofs. Okay? So I hope you have learned something from this discussion, and please, I advise you to be familiarized or to masterize or to know the different properties of your parallelograms, most especially the special properties of the square, of the rhombus, of the rectangles, because you will be needing that one, especially if you try to prove other theorems. Okay, so you will be using those concepts in the future. You will be studying, or you will be learning more on theorems in the future and the applications of those theorems in our daily life, perhaps, or in your other lessons. So that is all for this video tutorial. Thank you for watching and thank you for listening. I hope to see you on our next video tutorial. Stay safe and healthy always, mga palangga. Bye!